Hello everyone and welcome into yet another episode of our cookie clicker playthrough. Hell yeah! And today we yeah, it's not, of course. Yeah, the 610s. How can you imagine? Oh my goodness, if someone would be joining in for the first time, they would. It really would seem like I've just been playing cookie clicker for the past 610 days. Now I'm rendering in animation, of course. As always, as I always tend to be during these streams. I'm rendering in animation. Hi there, not enough cookies, I agree, but today we will not be... Hold on. Wait, why did I stop? No, that is the right card, never mind. For a second I thought it was the wrong card. Today we will not be playing cookie clicker, so get out of here, you. Today we'll be talking about statistical quantum mechanics. How late are you? You're not really late. This is the beginning. We haven't even gotten to the what will we do today section of live stream, where we are currently, so I guess we have gotten to it. Today we'll be doing statistical quantum mechanics. So, statistical thermodynamics. Yeah, kind of. Well, kind of. We'll also be rendering and making a video, so I guess I should also open up the script for this video, how math becomes difficult, and you are the greatest streamer, and I will see you again one day. Oh wait, is that you, Pizza Ranger? Oh my goodness, I have not seen you in such a long time. Are you leaving already? Well, if so, then goodbye and have fun, but if not, then oh, I have not seen you in a while. It's been such a long time. Oh, but by the way, I've been rendering this video. I am determined to make this video. Yeah, of course, I'm kind of committed at this point, spent hours on it. But right now, we are at this point. As you can see, here's my cursor open at the top. Which means we've already scripted and rendered all of this. This video is moving way quicker than the other ones. Probably because I'm finally not being a lazy piece of no good. Music, right. I did forget about music, didn't I? Hold on. Did I? Ah, I absolutely did not. Set up the music. There we go. And one more thing. There we go. Oh, that's groovy. Yes, that's, yeah, I mean, this will be statistical quantum mechanics. Since, you know, physics on a atomic scale is just statistical quantum mechanics, and then thermodynamics is just like statistical physics, and then statistical thermodynamics is statistical thermodynamics. Getting you through quantum mechanics? I'm glad I could help in any way. And now I'm finally making a video about calculus, among other things. You don't get live internet, lord. Hi there, Krish. Don't let the nurses know. Ranger, you good? Best principal. Of whom? I haven't gone that far. Hold on, I'm just starting with statistical thermodynamics. Oh boy, oh golly, oh gosh, oh darn, oh shicks and shucks, and all the others. Okay. So the reason why I'm, by the way, researching this is a video. Haha, shocker, am I right? Long time since I came here, yeah. The reason why I'm researching this is, of course, the video. The other one. Not the current one, only the other one. Which is, chemistry is just physics. Which will be... Take it events where was... Yeah, I'm just... That's the only piece of formal education I have, you know, formal education on swear words. This video will make me swear a lot. This will be a video about physics slowly transitioning into chemistry. Inventing swear words. Well, I do it quite a lot, so it shouldn't have that much of a problem. But yeah, so I thought we could just research stuff today and render. Right, the video is almost. This one is almost finished. Only 2 more frames. I actually might wait for 2 minutes. It's not a long time. Might as well just wait. Set up the next animation. Hold on. I'm gonna go. Bye, Andrew. Bye. Have a good one. Hold on. This Ghost Rider make it a thing now. I could make a Ghost Rider make it actually in 5 days. That's when I'm making. Oh, Ghost Rider. Oh, Spooky make it. Oh, it is October, isn't it? I think. Is it? Hold on. Is it? October. Yeah, it is October. I could make a Spooky make it. Tempting. I just cut the at Willem Gate. Okay. So, what's next in the script? Next in the script, there is... this. Okay, right, here's where we are. No, wait, no. Loclita's rule right before the equation works. X squared. Oh, I have to solve it. Why does it look like first principle derivative? Oh, you mean derivative? That was I have no idea. I'm not good with calculus. You know, it's difficult and whatnot. It has numbers and stuff. I will have to solve x squared. I will have to record solving it for the video. And you know what? I think it's funny if I just have like random things from the live stream on screen. Psych ward. Bye, Andrew. Wait. Thank you so much. Bye. Have a good one. Good luck, I suppose. Bye. Oh, pizza. Bye, pizza. I know what. Bye, pizza. Calculus is beautiful. I do appreciate its beauty even if I can't solve sums. Yes, calculus is really nice. I appreciate integrals the most, if I'm to be honest. Mainly because they are an outstanding tool. Okay, if we are to record this, I will have to get rid of... No, I got rid of the wrong thing. That's not what I have to get rid of. I have to get rid of all of these. There. Oh, it looks wrong. Ah, just a clean screen. Ah, awful. It's a clean screen. It's cringe. So now what we want, basically, is to press the record button and give me annotate and hide it a bit. There we go. Now I don't want to mess it up, but this should be this x plus h minus x squared h divided by, and then this should be equal to, and then with the equal sign we will have x squared plus 2xh plus h squared minus x squared, this all of it divided by h. And so then this one will be equal to x squared minus x squared, so these two will cancel out, plus 2xh plus h squared divided by h. And so thus this will be equal to 2xh divided by h plus h squared. And so cancel this, cancel this, cancel this, and so we end up with 2x plus h this time not divided by anything, and then so this will be equal to limit as h approaches 0, which will be of 2x plus h, which will be 2x, because this 0. I just realized how much I've messed up in the animation, and that's simply because this wasn't supposed to be infinity, this was supposed to be 0. Okay, I'm gonna fix it the make it way. And by that I mean I'm gonna fix it the make it way. Integration is just indefinite with new skills, so I like it. The reason why I love integrals so much is because they are so gosh darn useful. Hi the retrotivity, hi, how you doing? So okay, so the reason why I messed up so much is because right here I have an infinite sign. This shouldn't be infinity, this should very much be a 0. Oh no, the only problem is I can't just set it to a 0 and then just replace it easily, because I've already rendered all of the animations with this. Oh my, I really do just have a way of screwing myself over, don't I? Origin to geometry. It says X. It does also say X, you are right. I really messed up this animation, didn't I? It does say X. Okay. Oh my goodness. Was I drunk when I was making this? What's going on? Perfect. There. Look at it. Oh, lovely. Like the real thing. Okay. Alright, J, and then oh, we also have to get rid of this. That's so wrong. We're gonna have to duplicate this, and then... I mean, you can't even tell, can you? Well, this one has to be orange, so... well, whatever. Not color red, the color bright. You can't even tell! Now all I have to do is just render this, and like... And I don't know, we'll edit it later on. Later on we're just gonna edit it, and then it does say X tends to infinity. Why am I such an idiot? Yeah, we're gonna fix it in post. But I don't know the context. It should have been H tending to 0. You are correct. You are absolutely correct. The context is make it as a bloody idiot. Oh my goodness. It's fine. I can fix it in post. I can fix it in post. I'm good with editing. I can just fix it in post. It's gonna be fine. So, more difficult functions. On the arbitrary functions, we have this equation, and we'd like to solve it. Okay, so we only have a limit to solve. That is correct. Okay. Fix it in post. I'm gonna no, you all have no idea how often I screw up equations like this, where I don't notice that the equations are screwed up until after I render them. And after I render them, in order to fix this, that would be like 8 hours of render time. So no, I'm not gonna re-render the whole animation for no good reason. So I'm gonna fix it in post. Unless some of you have an idea of how often I do it, if you notice it in videos. It's subtle, but it is there. In one video, there's one video in which I did that, where I just replaced a number in editing. And you can tell, because it doesn't matter. I don't remember which one it is exactly. Okay, so now, let's say we want to... what does the script say exactly? Well, it's sort of a difficult function. Any arbitrary function, we have this equation, and we'd like to solve it. Now, this equation that I'm referring to in this case is equal to f prim of x, correct? Yeah. Oh my goodness, x tends to infinity. That's way wrong. Oh yeah, I didn't even register that x was in the equation. I just did x tends to infinity. I don't know why. I don't know, muscle memory for some reason. When would x tend to infinity? I don't care. It's irrelevant. Irrelevant, pointless. Gonna move it more to the right. And then right here, we're going to extend it out, of course. Because it would be silly if I was extending it in. That's inserting. Maybe wear smart panties. I'm always wearing my smart panties, my thinking caps. Okay, there we go. White, I suppose. There we go. And then we just need the camera to pan outside. So 40 frames should be enough. 40 frames is like a second. There we go. There we go. And there we go. This should be a bit bigger too. Okay, let's see. It's obviously blurry. That makes sense. But it is moving. Sweet. And in order to fix it being blurry, we need to not focus on it. There we go. I forgot to keyframe the other. I'm a bloody idiot. Well, I am. There we go. Position is fine. Okay. Sweet. Now render. Eat some ice cream. Oh, we got the ice cream. You're not even gonna share. That's mean. Be the first person with it. I thought it would be someone. No, I didn't want to get spoiled about the video. No, it's just derivative. Yeah, it's not. I'm not. I'm sorry. It's disappointing. I know. It's just basic maths video. Like we're on derivatives. We're halfway through it, and it's just derivatives. It's not that advanced of a video, except for the Fourier transform, which I haven't even scripted yet. I was supposed to script it before the live stream, but I felt really good, so I thought I should just stream instead. Yeah. Okay. Chemistry is just physics, or is it? That's what we're here to answer. Well, we're not really here to answer. We're here to script it. I am excited by Fourier. So am I. I love Fourier. If I had to rank transforms, Fourier would be my favorite. Laplace would be far behind, even though I know, but still. But I want your animations. Yeah, this video will be about something different. This video will be about how, like, going from the ground up. Fourier in a cup. Alex! Of course you joined in when I mentioned Fourier. I can see your... Is it diversifying? I don't know what it was the term is. You're becoming more general. Now you're not only joining in with quantum mechanics or physics in general, you're also bringing more towards math. I like it. For everyone who doesn't know, Alex is physicist who is the sole reason for why my second quantum mechanics video wasn't just a bunch of lies. So yeah. Speaking of, Alex, wow, you actually joined in at a good time, because I'm not talking about politics or nothing, I'm talking about physics, actually getting into physics. Escaping the dread of writing a report. How much time have you got? Because I don't want to be like, you know, if you need a distraction, I'm more than glad to provide you one, but I don't want to take up your time if you actually have something important to do. Why is my brain lagging every now and then? Just... Here we go, yeah. It's not really a time issue. Is it really not? Or are you just pretending like, nah, it's fine, it's not a time issue, I've got like 3 hours or something. Oh, because people have a nasty habit of like pretending as if they're fine when they're not. Ain't good. Ain't a good habit. So is it really not a time issue? Nah, it's fine. Did you hear what I just said about people pretending it's fine? Nah, it's fine. Alright then. Without any further... I'm not stalling. I am stalling. That was a lie. I am stalling. I'm just stalling. I have a second cup of coffee. I made two just before the live stream because the first one just ran out, so I knew I would need a second one. Let's get into statistical quantum mechanics. I like to call it. Okay. So, I should probably script... Well, classical mechanics will be simple. Thermodynamics... Actually, what would be the exact difference between thermodynamics and statistical thermodynamics? Okay, this time this is not me stalling, this is a genuine question. Difference between thermodynamics and statistical thermodynamics. The statistics. I see. In what way, however? Mechanics theory of physical pre-max understanding from a knowledge of microscopic concepts between culture particle, the relation between environmental variables, temperature, volume, making the process terms called thermodynamics. Yeah, but the reason why I'm asking is because, like, temperature feels like statistical mechanics. So, statistical thermodynamics, for example, when talking about temperature, that just feels like thermodynamics. Statistical mechanics is thermodynamics from grown-ups. Well then, I sure am glad that I'm getting into it. I just love mechanics. Don't worry, you... There are a lot of topics which you'll used to love. Used to, they operate work, used to love when I'm done with them. Now... Interacting identical molecules... I should make notes for this, actually. Notes. So, single molecule Hamiltonian, which is, I know it's basic, but I still want to note it down. Yeah, this is basically just like energy dust stuff, basically. One thing which is curious, which I'm guessing is part of the grown-ups physics, not baby physics, is that in this case we do have 6 different directions. As in, not directions, only 6 different what-have-yous, thingamabobs. So like 3 for position and 3 for velocity. I mean, I get it. Makes sense. So I'm guessing that's part of the grown-ups physics that I haven't done. Although I have came across it bunch. Okay, I can't make it bold, that's fine, whatever. I dt is equal to fraction of partial of... Oh, what is that h? That's just normal h. Fancy as h. That's just normal h. Fancy letters LaTeX. Mafco. Oh, thank you so much. Okay, I guess that makes sense, there's no Mafco. Fancy letters in LaTeX. Oh, welcome back, Pizza Ranger. How do you make fancy letters different? Because I know they are different. Isn't Word better? Word is... I don't use them, like, well enough for it to actually matter. Like, I don't know what kind of quality increase I would need to actually download Word. I need something that, you know, allows me to type in text. That's sort of it. That's sort of where my need for it ends. The reason why I'm picking Docs over a notepad is because I have equations in Docs and like titles and whatnot. I mean, you can't use a package. You know how to do hats and stuff. It's simple. Then why not notepad? Yeah. That's a question provided us, yeah. Okay, but wait, this is just LaTeX special characters. That's not what I'm looking for. You know what? Screw it. Just gonna do H. I know that there is like a fancy letter for 4, yeah. If I... Fourier transfer. A transform in LaTeX symbol. What's the symbol for you? Ah, that could answer my... I remember that walked in Google Doc. Piss off. Mafco L. Is it Mafco L? Damn it. It is something like that. Bro, how do you stay motivated? Caffeine. And also, every then nice comments, that helps a lot. Every then nice comments, not because they only every then now and then help, only because every now and then only I get them. Also, hopes and dreams, undoubtable human spirit, that's also there. General belief in humanity, love for science, certainly helps. Did I do Mafco incorrectly? If I did it incorrectly. No, I don't think I did incorrectly. Oh, muff sauce. The problem is that I don't think things with curly brackets walk in docs. Like, even if you do hat, you do it this way in doc. And then you type stuff in. Hat with... Yeah, hat with curly brackets doesn't work. So I need some method of making fun. Why am I trying so hard? My goodness gracious me. No, y'all can't let me get distracted. This is ridiculous. H. H is fine. P-I and Q-I. Partial P-I. P does mean just like position, right? And Q is just like velocity. I'm not messing it up, am I? Many space between partial and then command. No, the things with curly brackets just don't work. Like, I don't know if you noticed, but even when I do fraction, I just do it like this. Because fraction with curly brackets just gives you curly brackets. Won't Control C and Control V work? Ah, no, because if I Control C and Control V, it normally it's... Maybe actually. No, it's still H. Why does this stream feel different? Because it's another day. That's why. Time to do organic chemistry. Oh, I'm so sorry for your scat yet. I'm so sorry. I must be awful. This is Q, this is P. There we go. Okay, so wait. Frac 12 to type 1/2. That's so pointless. That's so unbelievably pointless. Yeah, I'll lead it. Okay, cool. Once you accept defeat and approach it from your perspective. Oh, so the approach is basically give up, go through the entire character arc. That's okay, I see. There's no day there on the left corner. Oh, yeah, right. You're so correct. Day 610, make it. There we go. Oh, you are so right. I forgot about playing back in. Drunken invisibility potion, exactly. Do you have a list of make-its? No, I have them all memorized. I know make-its, right? Some of them, they're my friends. Others are my enemies. You don't forget that. Do I have a list of make-its? Vector flank F. The two FM dynamical variables span the phase space. Phase space seems silly. I don't like it. No, the entire chapter. Okay, well then I guess sucks to suck for me. There's make it law? Yeah. Not really law, it's just make it. Phase space is space. I have a whole video about that. Like, the introduction video for my channel is just meet the make-its. For some reason it doesn't appear. Oh yeah, because of the rook. Okay. Wait, what is it? How long ago did I make it? I made it a year ago. Whoa, this... Okay, so like... This is around some really old videos. They are all 3 minutes long, as you can tell. They're old. There's a correlation line in between like time and length of video. As you can see right here, just Future Will Be Fucking Real was my first long video, and that was... And ever since then, I stopped making short ones because, oh my goodness, long videos are so much better. Quit getting distracted, make it! My goodness gracious me, physics! Phase space is a phase where macrostate system resides. Some of the term is used only for problems that can be described in spatial and momentum coordinates. Sometimes for all problems... for problems with some type of Hamiltonian equation of motion applies. Sometimes the term space state space, wrong, okay, state space is used for space of microstates in problems that cannot be described by only spatial momentum coordinates. Okay, so phase space is like space of all positions and velocities, and state space would be something like for an electron that has also spin. Am I getting that right? It doesn't feel right. It feels like guessing. Well, it is guessing. I'm gonna distract so hard. But yeah, no need, I'm already doing it myself. If the molecule is a single atom, we have only F is equal to 3 translational degrees of freedom, and the Hamiltonian is given by this. Makes sense. Alright, this makes all sorts of sense, because you see, this is H, that's G, H of Q, PQ, I did it backwards. I did just say PQ and then did it backwards. It mighty impressive of me to mess up so much so often. Is equal to, and then, what's wrong with me? Why can't I type? Is equal to 1 half M, and then all of them bad boys. Okay, P squared of XI, and then just a bunch of them. Is it bad I don't understand this equation? Never mind, I get it. Okay, never mind. I get it. Q is position. Okay, this is just... No, wait, divide by 2m. Position. That's an onion. That's not what... Okay. I know the Hamiltonian operator. That's the only one I know. Hamiltonian system is an operator. Okay, I guess that's the only one I need to know. Oh, so this is the total energy of a system. That's total energy of the system. Kinetic energy and potential energy. That's why it didn't click with me. That doesn't feel like all of them energies. First of all, okay, first of all, this is only P's. Describing translation. So this is Hamiltonian for translation. Right? In case of n atoms, 3 of the n equals 3n degrees of freedom are translational. I am struggling so hard. Alex, listen, I don't mean to be that guy, but like... help. I should probably just pick a different textbook. As in, simpler one, and then once we're done the simpler one, got to this one. Because whilst... Yeah... I'm jumping it too far. Three are translational, 2 or 3 are rotational for linear and non-linear molecules, respectively the remaining n 3n minus 5 or 3n minus 6. Okay, degrees of freedom. All of these things I recognize is known this way. That seems... Whoa, that seems like actually something that could be relevant. Oh, when you look up a topic and then it says in quotes the topic for the exact thing, yeah, that's probably related. In statistics, number of degrees of freedom is number of values in the final calculation of a statistic that are free to vary. That actually makes sense a lot. Estimation of statistical parameters can be based upon different amounts of information or data. The number of independent pieces of information that go into the estimate of a parameter is called the degrees of freedom. So it's the number of independent pieces of information that go into estimate of a parameter. Oh my goodness, that's so simple. Degree of freedom of an estimate. But by the way, the name is so misleading in this case. So let's try that again, knowing what degrees of freedom mean. The Newtonian equations of motion are very convenient for atomistic molecular dynamics computations. Statistical analysis of trajectories encountering such remedies can be analyzed in terms of thermodynamic properties, such as free energy. However, for analyzing the evolution of the system in terms of physical properties, the Newtonian description is very inconvenient. Measurement can provide the most theory shows Hamiltonian formulation of mechanics in the following dot end of shell. The formulation is very convenient for molecules that have rotational degrees of freedom. Okay, this makes a bit less sense. For that, we replace the velocity coordinates by momentum coordinates. No, it does make sense. Oh my goodness. For molecules with n atoms, 3 of the F is equal to 3n degrees of freedom are translational. 2 of 3 are rotational for linear and non-linear molecules. Same as you, just for quantum computing. Hide the brain in the shell. I am... Well, to say that I'm doing statistical thermodynamics is a bit of a stretch. I'm trying. Failing. If I try the C browser, it is... Git was recent having lots of tabs open. C browser, I have not. I better make it. Thank you so much, Ramit. Oh, that's so nice of you. Thank you. Molecules with n atoms free of the free n. Why free n? If you have a single atom, that would certainly make sense. Because, you know, then XYZ. If you have 2 atoms, it makes sense that would have more degrees of freedom because they can vary in different ways. How can 2 or 3 are rotational? Linear and non-linear molecules. That seems like all of them! Secondly, and the remaining 3n minus 5 or 3 minus 6 degrees of freedom are vibrational. Okay. I'm gonna be real. I don't get why this is 3n. Only 3 equals 3 times degrees of freedom. That makes sense! This makes sense. For a single atom with F equals 3, F being degrees of freedom. This makes perfect sense right up to this point. Why 3n? I missed something. With the single Hamiltonian molecule Hamiltonian, the equations of motion for m not iterating identical molecules with f degrees of freedom for each molecule read. With a single molecule Hamiltonian, the equations of motion for m non-iterating identical molecules. Okay, so we have a molecule and we have m molecules. That's how many molecules we have. With f degrees of freedom read. So fm makes sense. F because that's the degrees of freedom, and because that's the amount of molecules, so that makes sense, right? If you have like 2 molecules, they are both in different places, going in different directions, you need all of that, and based on all of that, the result will vary. The 2, the 2 because you have 1 for position, because... F is the direction, so 2 because you have velocity and I don't feel confident in this. Okay, no, it's fine. I'm fine with this. No, it's good. It's science, mathematics, simple stuff. Why 3n? Who knows? Why not, honestly? That's probably why. Like, this is perfect. F is equal to transitional degrees of freedom. So, translational. Let me just make sure that... Okay, well, fine. Okay. It's not a brain fry, I'm fine. I can figure this out. Can I get like example? Different example. Okay. No, I like a example for dummies, like for someone with limited brain function. Still lagging. I know. I can tell. Need the reference for that. The one. Okay, hold on. Structural equation models sounds like something I could be interested in. When the results of a structural equation model are presented, they generally include one or more indices of overall model fit. The most common of which is G2 statistics or G2 statistics. This forms the basis for one of the indices that are currently reported. Those for statistics that are more degrees of freedom, more fit, as well as the nature of model itself. Degrees of freedom are computed as the difference between number of unique pieces of information that are used as input into the analysis, sometimes called knowns, and the number of parameters that are uniquely estimated, sometimes called unknowns. For example, in a one-factor combinatorial factor analysis with 4 items, there are 10 knowns, 6 unique differences among 4 items and 4 item variances, and 8 unknowns. Hi, the Spoon, how you doing? 4 factor analysis for variances with 2 degrees of freedom. Degrees of freedom, the name of model. But if no other reason than that, all else being equal to fewer degrees of freedom, the better interest will be. Mate. Oh, so thank you so much. 11, there's 2 now. Yeah, you're right, I know to tell you, that's kind of what happens when you do statistical thermodynamics. It's a thrilling topic for a live stream. Hi, the lamppost, how you doing? I might need an introduction to statistical thermodynamics. Is it like a for dummies introduction? Okay, for the fundamentals of probability sounds like a... I'll just skim through it really quickly. It's fine, whatever. How's the animation doing? Oh, it's almost finished. 6 more minutes. Okay, it's a probability, basic probability, alright. Yeah. Average of X. Oh, I'm an idiot. Oh my goodness, that's what the notation was. I am not doing well with this, apparently. My brain is just... Also, why isn't this loaded? That didn't help, by the way. Just highlight. Copying or something. Doing good. I'm doing my exams and years. I delete every social media. Send my long. That's why I still have a little bit of time. It's fine if you have exams. I understand completely. Because the limited sensitivity is infinity, but with X. Mechanics, since n is large, X may be considered a continuous variable. Evaluate using this expansion. Okay. Then we have this basic stuff. Remember when I said that this probably should be for beginners? Because yeah, it's not. Shocker, it's super not. I think I might need to do a video about probability before going into this. I don't think it was a bad idea. I do have another video, which I would like to do, but that would require me to show a PDF on stream, which I am not comfortable showing publicly. You have a fun thing to tell me? What's the fun thing? I hope it's fun, and not like fake fun, where someone tells you it's fun, then turns out they're just telling you about, you know, starving people in the USA in relation to the amount of food wasted. This whole thing. Or about how mixed race dating wasn't allowed in one of the universities up to the year 2004. Was that kind of fun? Also, how about Robert Downey Jr. is older than desegregation? What kind of fun is it? Quit building up the tension. I'm running out of silly American moments. I mean, 100% of food goes to all living things, like, eventually. You just need to wait. I was telling everyone about believe such a thing as someone they could do it. So it sounded exactly like me? No, that wasn't me. No, I would never why would I compliment someone's outfit? That wasn't me. That wasn't me. That wasn't me. That wasn't me, just in case you wanted. That wasn't me. Someone else. Yeah, that random person who totally wasn't me. That was quite a moment, huh? It was a nice bald eagle statue, though. Coffee! Okay. This is a bad idea, make it. Also, don't talk to yourself in third person. Second person. Makey Bakey. I'm really hoping you call them Makey Bakey. That would be a funny thing to hear with no context. I'm going through a really difficult, like, inner conflict at the moment. Because on one hand I really like the idea of this video, on the other, this would require me to learn a bunch of maths. So I mean, it wouldn't be the easiest for me. I feel like studying chemistry would be easier. I guess this will eventually end up as being chemistry. I could just script the classical mechanics portion, then move on to thermodynamics, and that way force myself to finish this video, because then I would waste time if I didn't. Makey, but it's not a nakey. Dude must have been molested. Don't say nakey to random people, especially in the name of me. Trust me, I've been there. This leads to so many lawsuits. Okay. Now, what's next in our animating lovely thing stuff? A limit to solve. Oh yeah, right here we just wanted to make it glow, okay. That's pretty simple. Make it, huh, kids? Like me. guessing color bright 100 should also be there. Plain making, yeah. Differentiate from all the other makers. What a savage. It's such a nice render, isn't it? Like, it has a background and stuff. That's nice. I actually need to wait for this render because yeah, like it's a single frame thing. Why do you mean stream for an hour? It feels like 20 minutes. I mean, I've rendered one animation. Okay. Oh, now the left side. That's gonna be festive. The reason why being is because the left side needs the exact same thing, except... Oh my goodness, okay, call it this. Except on the left side we need... actually white bright 1, except right here we're gonna need 100 and then assign, and then you, there we go. Nope, we're missing one thing. How's it going? I'm fine, I'm so fine, I'm doing so fine. I'm doing so fine, I'm doing fine. White bright 100, there we go. Ta-da! Statistical thermodynamics. That's not a good idea. That's not a good idea. I think we're a pretty cool video, but I don't know enough about the topic. Or a red orange t-shirt. I'm Santa, kid stealer. Can you... Why are you so obsessed with this? Kinda brain scratching while... No, I scratch my own brain. I don't need my brain scratch. Why is it so orange? That shouldn't be... Well, green and red... Oh, this actually might end up orange because of all the... No, that doesn't make sense. I think I might have set everything on the left as... Fudge sticks! Did I set everything on the left as color bright 100? Oh my goodness. No, I meant this. And this. And this. As green 100. And I meant this as white 100. And then this also as white 100. And then this as white 100. And now render. And now it's more varied. How sweet. No, I didn't mean the X. Fudge, I did backwards. This was supposed to be green. And you was... And you too, actually. They're supposed to be bright. There. To get my sanity back. Have a good one. Bye, lamppost. Have a good one too, and good luck on the exams. Oh no, this is just plain. I don't care. No, I'm leaving that. Like, yeah, I'm just leaving it. Okay, now select all the white brights like this, and then just white bright. Select all the color brights like this, and then just color bright. Select all the green brights, and then just color green. And now you want to be color red. Ah, we're back. Okay, what's next in the script? Loplita's rule. Loplita's this is awful to spell. Limit of the point C. How am I supposed to animate this actually? Why that, and why also why I accent animate this weirdly? Okay. Image, save, whatever. Now we need to use Lopita's rule, which I'm not actually sure I can paste into Blender's text. Can I? Which will suck. I can! Sweet. Never mind. Doesn't suck. It's great. Lopita's color. Bright. Rotate negative 90. Rotate positive negative 90. Positive negative 90. And then scale down like this. And then just animate it going down. Okay, maybe a bit higher up. There we go. Alrighty then. So, back to this stuff. I could just script classical mechanics and that would force me to learn statistical thermodynamics later on. And thermodynamics in general. Yeah, I think that's the best idea. Fine. Okay. First things first, the classics. Classics mechanics. Classical mechanics. Well, okay. Wait, position is P. I'm trying to work it so hard. It's fine. Position P, velocity V. That's control V. V. Radius. In a time T. That is all you need. It's more or less actually. This is gonna be a really short chapter. I'm just gonna, yeah, this is gonna be a really short one. Relation to these main four. Yeah, I'm gonna say main four because the fifth one I have a different point for it. example, quality of force. Well, this quality basically means that no matter what force you apply, will be equal, but only some of these can change. Actually, velocity and time, I guess that's not that important. Or is it? I mean, velocity with position and time is what I meant. Velocity actually is important. Acceleration isn't, because acceleration will just be a consequence of force. Well, actually, acceleration would just be a consequence of velocity. And in order for something to accelerate, it has to be... Oh, does it actually? No, accelerate, because yeah, accelerating is like an active thing. Mass cannot change. I like it's... I feel like the idea is pretty simple. Have a chair and push it. Chair isn't suddenly getting heavier, so no matter how pushing on it won't make difference. Time can change. Force has no. Oh. Yeah, okay. Keep going forwards. Position, however, and position in relation to time especially can change. And so when we push an object forward, order for this equation remain equal, we have to change position and velocity. Oh, I see coordinates. The reason why it's so key for me to keep velocity and acceleration separate in this case is because, you know, velocity can remain constant without actually needing energy. Constant, you need energy. 5 meters. It can just stand there, right? Enough. It can just stay there. Do you do any programming? I used to do a lot. Now I don't do a lot. I used to do a whole bunch of programming, but then I just stopped. Actually, recently we did some, I suppose. I suppose recently we did some. I suppose recently we did this. I guess I don't need to just build main. There's not build client main, sorry. I guess this is what... That's what we did, just a graphical engine. Also has transformers, that's cool. And also doesn't crash, that's a neat thing. But that's an OpenGL. A while back ago I also did one in Vulkan, but that one didn't have text. It did have a absolutely banger of a DLL loader. And shared objects loader, it was really cool. We'll still be traveling forward. Okay, yup, those are the ones. What else do I need to explain? Mass, time, pretty simple. Position, pretty simple. Velocity, pretty simple. Radius. There we go, radius. I might have noticed that... Main 4, I did. Yeah, apart from our main 4, we also have a 5th one. Basically, the only two things I want to mention in this chapter is the real basics of classical mechanics and derivatives. Like, how all the things are more derivatives than divisions. Because of the whole 0 by 0 dilly. Yeah, so basically... And then a disclaimer too, because, well, yes, radius is only relevant to the sphere, like, you know, radius wouldn't be relevant to other objects like chairs or something. There is a certain asterisk, because not everything has mass. Okay, and there's and then thermodynamics. Speaking of, I feel so bad for just, you know, sitting here in silence. Though actually, I'm sorry. Normally I chat a lot more, make jokes. I'm really funny, but well, in this case, okay, this one. Oh wait, is it in this the book in which I said it looked really basic, but then turns out it wasn't basic, and then I was like, oh no, yeah, partial derivative second. Oh, never mind. This actually looks... does it look simple? I do believe this is the book where I was like, this is simple, and then it turns out it wasn't simple. Now let me just do something real quick. Oh. Yummy. By the way, Quentin, I know if I said hi. I'm so sorry if I didn't say hi. Hi there. How's the day going? Just in case I didn't say hi. How rude of me. Okay. Alright. Might as well include them. Also has the animation. Still cranking. Cool. I must include them. Another important. Mechanics is the fact, though, we can think of velocity as distance divided by time. This is actually equation for average velocity. Yeah, that is actually the reason why I am making this video. I mean, okay, not this video specifically, but the reason why I wanted to make a math video is because I have made so many videos in which I'm like, oh yeah, there is a derivative, and I had to explain what the derivative was. It's painful. It's painful. Now I can just each time say, hey, I made a video of maths, go watch it. Over there I explain what derivatives are. Thermodynamics, and now we're starting our research. Sweet, finally got there. Oh my goodness, took me long enough. So I can see that viewership dropped to 0 right now. For half a second. For half a second, the viewership dropped to 0. Okay. Thermodynamics. Sweet, everyone's favorite. Hidden thermodynamics, right. Simple. Introductory remarks. Let's go through it one by one. Yeah, we definitely been over this. Take a second to remember that. Extensive intrinsic quantities, okay. Okay, so intensive depends on amount of material. Okay, right away, notes, you know, what could be useful. Thermodynamics and other stuffs. Thermodynamics. Once again, we're rushing through it because this is basic. Small. Nope. That one I'm just gonna skip. Prepositions playing upon the heat may be supplied to a system or lost from it. Work may be done on gas or by it. System has lost 5 joules heat, gained 5 joules. Okay, simple. Alright. lots and lots of questions. For example, equation the increase the energy system is okay. Alright, partial derivatives. Seems like a simple enough starting point, in my opinion. Just derivatives, but for parts. Introduction. Okay, that's quick. Nice. Equation represents two-dimensional surface and three-dimensional space. The surface intersects the plane y constant in a plane curve which z is a function of x. One can then easily imagine calculating the slope or gradient of this curve on the plane y is constant. Alright, let's figure out what I just read. An two-dimensional surface in a three-dimensional space. Okay. The surface intersects the plane y. Y is equal to constant in a plane curve in which z is a function of x. The surface intersects a plane, y is equal to constant. Hi, Desentray. Pretty sure I'm going to do a Make It video marathon. Watch every Make It vid this weekend. I wouldn't recommend. Don't watch any videos that are before the future will be fucking great. They are boring. I wouldn't recommend. As long as I would recommend the marathon to only do it from the future will be fucking great to the current one. So the long videos, the short ones really suck. That's coming from the creator. Trust me, no. Trust me, the old ones aren't great. This slope is partial derivative of z to x. So how z is changing in relation to x. Wait, where? Basically, I mean, it's pretty... Hold on, let me show you. Right here. 25 minutes. That's how we know. All of these are short and they suck. Like, this video has 2,000 views and has also one of the highest... This is also one of the highest disliked videos. Because it's explaining derivatives... not pointers. My goodness, my brain is really struggling. Pointers. But it sucks. This one also sucks. This one is funny as a joke, but kind of sucks. This one, it's alright. This one sucks. Well, okay, no. Fire Destroyer was cool, special. Sucks, and so on. No point. Yeah, that's how I would recommend, because the other ones are really awful. But hey, good luck at school. Pointing to some of your memory in C? Yes, that is what it was supposed to explain, yeah. Partial derivative with y being held, for example. Okay, so this, the derivative, partial derivative with y being held like this, is of course y divided by x, because the derivative of natural log of x would be 1 divided by x, and y is constant, so we just multiply it. That's simple enough. Make it by Zentray, bye, have a good one. So that is simple enough. Obviously, which one being constant. Intimate diameter of the model variables, and usually I was always essentially indicate as quantity being held constant. Okay. So, evaluate z at xy. Now we increase x by, I think it's lowercase delta. I'm not certain, but I think so. What will the resulting increase in z be? Obviously, first order. Okay, the derivative. Y increases by the y, it will increase z. Okay. Z to the first order will be this. That makes sense. Chapties will have partial derivatives. Why isn't this like a... Wait, whoa. 1 point... Huh. It's curious. Okay. Hi, I'm preparing for the advanced need tips for maths and chemistry. For some reason I forget formula even though I'm able to solve. If you're forgetting formulas even though you're able to solve them, I would recommend trying to find the meaning in formulas instead of just memorizing them. All formulas at the end of the day have an underlying meaning and have a reason for why they are the way they are. So try to find that meaning, and when you find it, then you can just like derive the formulas every single time you're doing it. So for example, what would be a good example? Let me think of something. I'm struggling. Okay. Why is my mind blank? Hamiltonian operator? I feel like it's kind of an example. Forgot electromagnetism formulas. Yeah, I mean that happens. I can relate to that because formulas are so annoying to just memorize, in my opinion. And the fact that, you know, schools kind of force people to memorize them is sucky. But okay, if you're doing that, then I guess you get what I mean. I don't have to, yeah. Okay, for example, like question. Okay. Can you make a video on problem-solving approach? I would love to. The problem in that approach, pun intended, of course, pun hardly pushed, is that there are a lot of much better videos. The two that I always mention are the absolute math legends, which is Freeborn Brown for when you need to understand the formula in order to replicate it, and then a black pen, red pen, if you want to get good at solving stuff. I really don't have much input, which these two giants haven't really done, so yeah. That's why I don't think I'll make any problem-solving videos. I'm sharing this channel ASAP. Oh, thank you so much, Aizen! Thank you! Thank you so much, I really appreciate it. Lord knows I need it. Humble. I'm not really that humble, I'm just not quite as amazing. I really have nothing on Freeborn Brown because Freeborn Brown is a platinum standard of explaining maths, and Black Pen Red Pen has videos like, for example, solving 100 integrals or solving 100 derivatives, solving 100 limits, solving 100 Laplace transforms, videos like these. And over there, you know, if you solve along with someone 100 integrals, then you're gonna get pretty good at solving them. Okay. Then we have this, which, well, I guess it's partial derivation. Okay. Depending, the only way in which equations can always be true if all expression be planned to be 0. Okay. And this. We often deal with more variables than just x, y, and z, which can be constants. For example, we are dealing with u, v, w, x, y, z is not generally true. That okay. Important relation like this. Okay, so this is just like circular. Yeah, this is circular derivation. I don't know, it's called the circular derivation. That's how I always imagined it. Alright. If z is equal to z, you can go through motion of calculating this when further calculating second derivatives. We should be found the last two. Make second derivatives equal to... Okay. Let z is equal to x sine y. Show that this. And then right away solution. That's how convenient, because I was not going to solve it. I'm awful at solving stuff. And by that I mean I'm just dumb. That's it. That's why. Okay. There's just one value of z. Oh, right, that is... Oh, yeah, that is a possibility, I guess. I didn't think of that. I forgot that... Oh, yeah, when you're dealing with three-dimensional stuff, that should be pretty common, right? Oh, no. It's foreshadowing for the future. Sufficient condition makes it... Okay. Calculate the difference, z, in heights of A and C. Go from A to C via B or via D. A to C via B or via D. Right. Okay, this is just solving a partial derivative. Yeah. This may it's giving example by giving values for intensity variables PV and T, the pressure, molar volume, and temperature. That is, the state of the system can be represented by a point in PVT space. Often there will be no relation, no instant state between the variables. For example, volume and your gas, the variable related. Okay. Alright, this makes sense. This is just like derivatives and functions. Entropy S internal energy U, where a function of state S and U are uniquely determined by the state. V and T, you can calculate S and U or any other function of state. In this case, any difference of the... Okay. The internal energy U of a system is defined in such a manner when you add a quantity Q of heat to a system and also do an amount of work, dW, on the system, the increase, du, the energy of the system is given by this. That makes sense. I would say that's pretty... Okay. I would say that makes sense. Where U is the internal energy, Q heat, quantity of heat, just heat, work. Alright. You're gonna be no function of the state of the system. Inexact differential? I'm sorry, what? It's not an exact differential. Well, what's the point of having a symbol for an inexact differential if it's also used for an exact differential? I feel like that might be a bit suboptimal. Okay. Euler's theorem for homogeneous functions. Of course it's Euler. Why not? Of course it's always Euler. Yeah, Euler containing... Usually credit to Euler. I'm so glad Euler finally got something credit to him. That guy is just always omitted in maths. Function being used of... Okay. Function of degree n of the variable xyz is a function in which all terms are of degree n. For example, the function xyz is equal to ax... I'm not reading that, there's no point. Okay, never mind, I get it. Oh my goodness, okay, that's simple. All terms are of degree 3. Yeah, because all things are basically multiplied by 3 things. You get it. Find easy to validate partial derivatives of all of them. Huh? Yes, because the other ones are constant. Equally easy, is 19 is to validate the expression of this. Yes, because there will be 5 million characters. This is not... I do urge you to do it. The answer is this. 3 of everything. I see how that would be. That certainly makes sense. What's... This is equal to 3f. Ha! Feels important! Find this is equal to 2f. Okay. In general, a homogeneous function of xyz of degree n is always in the case that this. I'm just one... I have one question. You know, it might be just me being silly, being a bit of a goofball, being, you know, a bit wacky at times, but... What's a degree? Is it the same? Is it just statistical degree? Because I think it is, because it's using the same character. It's f. And this is a degree. And this is, you know, like I can just look it up. Yeah. Degree of... Oh, that's not... Is it the same degree or not? Simply the degree. No, that's not what I'm looking for. Don't include those search results. Look only for this. Okay, I see the problem. Natural function f and variables. No, I'll be right back. Give me a second. No, that's wrong. Whoops. There we go. Guess who's back? It's me. Make it. I'm back. Who did you think was back? Okay, never mind. The point is, of degree K. So it's degree. Degree n variable is a function in which all terms are of degree n. Okay. I think makes sense. I think. What's the theorem here, though? Is it this? Oh, this. I see. Okay, I suppose we will see when that's useful, why it's useful, or why it's important. Let's... Oh, my beloved Psi, you were so back. Function of x, y, and z. Then if x, y, and z are independent variables, one would ordinarily understand that where psi is a maximum, the derivatives are 0. Yes. Yeah, obviously. I know what I'm thinking about this. If the derivative wouldn't be 0, then you could just move up. I know why you're gonna be thinking this. Okay. X and Y are not completely independent, but are related to some constraining equations such as equal. The situation is slightly less simple. Now in context, the three variables may be, for example, three intensive state variables, P, V, and T. Psi might be the entropy, which is a function of state. However, some intensive state variables may not be completely independent since they are not related to equation of state, such as PV equals RT. If we move in terms of displacement dx, dy, dz from a point where psi is maximum, the corresponding changes in psi and f will both be 0, and therefore both of the following equations must be satisfied. Let's think for a second about why. From a point where psi is a maximum, the corresponding change in psi and f will both be 0. So if we move away from the maximum a little bit, and if we add together all derivatives multiplied by the change, that basically means taking all the slopes distance. I misunderstanding something key here? I mean, I am, obviously. Sine f this. Arbitrary constant or satisfy a similar equation. Then multiply and again multiply. Often some additional information is an actual problem enables the constant to be identified. In summary, the condition is that psi is a maximum or minimum or saddle point if x, y, and z are related by a functional constraint. F of x, y, and z is equal to 0 are this. What's psi in this case? That's psi, correct? I think. I don't know. What's the character in this case? With this? Are variables with several constraints, such as FGPD, HGPD, etc., or FGH. There are functions connecting all or some of the variables. The conditions for psi to be a maximum, etc. are. Okay, so in order for psi to be a maximum, this is damn not smart. For psi to be a maximum are this. Oh, that's a misclick. No, what I meant this. I'm still trying to let's go over it again. Okay, this one is trivially simple, of course. So it's just slightly less simple. The free variables may be, for example, free integer variables. We want to be say, however, the state variable may not be completely independent since they are equation states. Okay, yes. If we move by displacement dx, dy, dz from the point where psi is the maximum, the corresponding changes in psi and f will both be 0. Therefore, both of the following equations might be. Okay, so we're moving away. Okay. We're moving away. Oh, that makes sense, I think. We're moving away by an infinitely small distance. And because of what derivative is. Okay, yeah, okay, that makes sense. So if, for example, you can imagine as like top-down view, okay? If we have a point with two coordinates, x and y, and this point is at its highest right here, then if we move away by an infinitely small distance to the x, infinitely small distance to the y, then by definition, like the slope into the third dimension, this is, obviously it's two-dimensional, you can't really see it, but the slope in the third dimension would have to counter this dx. So it makes sense that this would be 0. Wait, it's multiplied. See, multiply is where you look. No, because it's no. Not because it's negative. Wait. It's 0. So all of them have to be 0 because I don't really see a reason for only some of them to be negative. And thus, the derivative going this way, and then going up, and multiply them together. Why multiply? That's a good question. And then 0, huh? It can't be just because it's an infinitely small value. That wouldn't make much sense. Way too simple. Any linear combination of psi and f, such as this, where lambda is an arbitrary constant, or satisfy a similar equation. Okay, so like psi. Okay, so this plus this multiplied by a constant would satisfy a similar equation. So what do you mean similar? I mean equal to 0. The condition that psi is a maximum or minimum saddle point. Okay, so any like flat thing, I get it. If x, y, and z are related by a functional constraint, f x equal xyz is equal to 0 are this. Okay. And this is this function. All right. Okay, almost there. I'm almost clicked in my brain, all right? Where this is... Okay. So we have a functional constraint. F is equal to f of x, y, z is equal to 0. Then... I'm fine, I'm figuring out, like, it's almost there, I'm almost there, it's almost clicking for me, okay? I'm just trying to imagine it in my head. I think I get what this means. So if we are at a flat point in the function, and they are related by functional constraint, then what would this be? Well, this would be a flat point plus the functional constraint multiplied by some constant. We don't care about the constant. I mean, we do care about the constant, but we don't care about the constant. Then the derivative of how this one changes in relation... Okay, I think I get it. I think I get it geometrically, which isn't great. I would much better if I understood it mathematically in, well, like calculus wise. But it's good enough. I'm gonna take a win when I can get one. Of course, if psi is a function of many variables, okay, and the variables are restricted to several constraints, okay, or FGH is a function of variables, the conditions for psi to be a maximum are this. We need different constants for different constraint. Alright, quick refresher on what are constraints. Yeah, I don't think we're gonna get there. Oh! Okay. Got me one. Got me a catch. Where's the ideal gas? That is constrained to lie on a two-dimensional surface. Three-dimensional PVD space. Okay. Necessary to specify only two of the three variables. So constraint in this case would be just like, well, f of x, y, z is equal to 0. I guess was a bit of a tip for that, but so constraint here is basically like a function with no derivative. Right? Right? I'm not confident because I don't know what this means. I know y is equal. I know that much. I know why. There's no one watching the live stream, by the way. Zero viewership. That's what it's saying. It's a viewership of 0. It's, yeah, every now and then you get a spike, but I get it. Should I do it off stream? I feel like that's one of the things I should do off stream. Viewership was 0. Okay, you know what? Message received. Fine, I'll do it off stream, and then I'll come back once I have something interesting. Anything. Anything has to be better than this. So, I'm really sorry for this live stream then. I should have seen that coming. I will come back next time, have learned at least some of the statistical thermodynamics, because that's clearly not something that's not a... Wow, consider me shocked and surprised. You mean to tell me that statistical thermodynamics isn't entertaining to watch? Shocking. Anyhow, I suppose for now that'll be it. Thank you everyone so much for watching, and have a great day. Bye.